lines and angles. In this module, you will learn about lines and angles. Let us learn about lines and angles. Suppose there is a ray OP on a plane with endpoint O. With the same endpoint O, consider another ray OQ in the same plane. You observe that OQ is obtained from OP through suitable rotation around the point O. We say OQ subtends an angle with OP. The amount of rotation is the measure of this angle. We use a numerical measurement called degree to measure angles. The rays OP and OQ are called sides. O is the vertex of the angle. The angle POQ is denoted as. There are many types of angles. Some of them are as follows. Straight angle. Consider a straight line and let O be point on the straight line. Then O divides the straight line into two rays. If B is to the left of O on the line and A to the right of O, then there are two rays OA and OB. Angle between these two rays is called a straight angle. Right angle. Right angle is that angle which measures 90 degrees, or you need half of a protractor. Acute angle. Acute angle is one having measure less than 90 degrees. Obtuse angle. Obtuse angle is that angle which measures more than 90 degrees, but less than a straight angle. Reflex angle. Reflex angle is an angle measuring more than 180 degrees, but less than 360 degrees. Complete angle. Complete angle is an angle measuring 360 degrees. This corresponds to a complete revolution of a ray OA around the initial point O. Supplementary angles. Two angles are said to be supplementary angles if their sum is 180 degrees. Similarly, the angles are said to be complementary if they add up to 90 degrees. Adjacent angles. Two angles are said to be adjacent angles if both the angles have a common vertex and a common side. While measuring lengths of line segments and angles, we observe the following rules. We can take them as additional postulates. Rule 1. Every line segment has a positive length. The length of the line segment AB is denoted by AB, or modulus of AB. Rule 2. If a point C lies on a line segment AB, then the length of segment AB is equal to the sum of the lengths of segment AC and segment CB. That is, AB equals AC plus CB. Rule 3. Every angle has a certain magnitude. A straight angle measures 180 degrees. Rule 4. If rays OA, OB and OC are such that ray OC lies between ray OA and ray OB, then angle AOB equals angle AOC plus angle COB. Rule 5. If the angle between two rays is 0, then they coincide. Conversely, if two rays coincide, the angle between them is either 0 or an integral multiple of 360 degrees. Note, if the angle is measured anti-clockwise, it is positive. If it is measured clockwise, then it is negative. Now let's prove some propositions using the axioms and postulates that we have learned. Proposition 1. Let AB be a straight line and OC be a ray standing on the line AB. Then prove that angle BOC plus angle COA is equals to 180 degree. Given a ray OC stands on a straight line AB, forming two adjacent angles BOC and COA. We have to prove that angle BOC plus angle COA is equals to 180 degree. Proof. We have angle BOC plus angle COA is equals to angle BOA by rule 4. But angle BOA is a straight angle determined by the line AB, so we can say that angle BOA is equals to 180 degree by rule 3. Now we can invoke axiom 1 as angle BOC plus angle COA and 180 degree are both equal to the same thing, which is angle BOA. We conclude that angle BOC plus angle COA equals to 180 degree. Proposition 2. Let rays OA, OB and OC are three rays such that OC is between ray OA and ray OB. Suppose angle BOC plus angle COA is equal to 180 degree, then AOB are collinear, that is, they lie on the same straight line. Now we will see what is given. Three rays OA, OB and OC are such that angle BOC and angle COA are adjacent angles, which add up to 180 degree. What we need to prove is that AOB all lie on the same line. Proof. For these we need to do the construction. Extend AO to D such that AOD all lie on the same line AD. Using proposition 1, we have angle DOC plus angle COA is equal to 180 degree. But we are given that angle BOC plus angle COA is equal to 180 degree. Using axiom 1, it follows that angle DOC plus angle COA is equal to angle BOC plus angle COA. Now use axiom 3 to get angle DOC is equal to angle BOC. There are two possibilities. OB lies between OD and OC, or OD lies between OB and OC. In the first case, using rule 4, we get angle BOC is equal to angle DOC is equal to angle DOB plus angle BOC. And axiom 3 implies that angle DOB is equal to 0. In the second case, rule 4 gives angle DOC is equal to angle BOC is equal to angle BOD plus angle DOC. And axiom 3 implies that angle BOD is equal to 0. Thus, the angle between the rays OB and OD is 0. Using rule 5, we conclude that the rays OB and OD coincide. This means B and O are on the line AD. Thus, AOB are collinear. Now let's move on to the third proposition. Proposition 3. Let AB be a straight line and let OC be a ray standing on it. Let ray OP be the bisector of angle BOC and let OQ be the bisector of angle COA. Then angle POQ is equal to 90 degree. Given ray OP bisects angle BOC and ray OQ bisects angle COA. What we need to prove is that angle POQ is equal to 90 degree. Proof. Since ray OP bisects angle BOC, we have angle POC is equal to half the angle BOC. Since ray OQ bisects angle COA, we also have angle COQ is equal to half the angle COA. Adding these two and using rule 4, we obtain angle POQ is equal to half the angle BOC plus angle COA. By proposition 1, angle BOC plus angle COA is equal to 180 degree. Thus, we obtain angle POQ is equal to half into 180 degree is equal to 90 degree. Proposition 4. If two straight lines intersect at a point, then the vertically opposite angles are equal. Given AB and CD intersecting at a point O. To prove is that angle BOD is equal to angle AOC and angle DOA is equal to angle COB. Proof. Consider the straight line AB and the ray OD standing on it. Then angle BOD and angle DOA are adjacent angles. By proposition 1, we have angle BOD plus angle DOA is equal to 180 degree. Similarly, considering the straight line CD and the ray OA, we see that angle DOA and angle AOC are adjacent angles. Thus, proposition 1 again gives angle DOA plus angle AOC is equal to 180 degree. Using axiom 1, we can compare 1 and 2 and get angle BOD plus angle DOA is equal to angle DOA plus angle AOC. Since we can remove angle DOA using axiom 3, we obtain angle BOD is equal to angle AOC. A similar argument gives angle DOA is equal to angle COB. Let us revise all that we learned in this module on lines and angles.